or simple regression, etc., etc. So today we'll learn about it. So, why do, businesses do regression? Correct? That is important, right? So businesses most of the time need to understand, the relationship between two or three variables to take a decision. For example, you might, a logistic company might need to understand the cost. Amazon is there. It might need to understand the cost of transporting its goods, right? Based on the weight. So 20 grams could be X and Y cost. 100 grams could be X and Y cost. So you need to predict it. That's an example. So here, if you see, a marketing company may need to understand the relationship between its advertising spending and its sales. How much spending is it doing and how much is it translating into sales. Sales department also, might need to understand the relationship between the price of its product and the volume of its units sold. For example, Pepsi or Coca-Cola is there. So it might need to understand the price point or at which the most number of sales would be there. Or if they increase the sales, what would be the volume of units sold. And an investor in the stock market, might need to understand the relationship between repo rates and the stock market returns. Repo rates, are the ones which RBI gives so that banks could borrow, from RBI. So all these are important, and there are many other use cases for, understanding the different relationship between variables. So we will study the concept of correlation first, before understanding regression to quantitatively estimate, an relationship between these variables and also explore linear regression. Okay. So first is correlation. Now correlation is basically the relative strength between two variables. So it's like if one variable is increasing, how is the other variable moving? Is it increasing or decreasing, or is there no effect on it? Okay, it's basically how they are related. Okay, examples could be, what is the correlation between rise of incomes and rise in house sales? Is the median, middle class incomes are increasing, and that's why there's an increase in house sales or a decrease in house sales? And what could be the correlation between inflation rate and amount of savings deposits in banks? Right, inflation rate can affect savings, right? And also, what is the correlation between crude oil fluctuations and also petrol price in India? Is the barrel is a barrel of oil price increase causing a increase in petrol, or is it something else? What could be it? So to quantitatively assess this correlation between two variables, we use the Pearson correlation coefficient, and it is named after Carl Pearson, who developed it. Okay, and it is a measure of linear correlation between two variables. Now, linear correlation is basically it's either increase, decrease, or no relationship. So that's what linear is, and the value ranges between -1 to 1, which does represent the strength of the relationship. A value of +1 would be that it is perfectly positive correlation. So it's like as one is increasing, the other one definitely increases. And a correlation of -1 means perfectly negative correlation. So if one is increasing, the other one is decreasing. And a value of 0 means no correlation at all. So as one is increasing or decreasing, the other one has no relationship with it. Okay, let's see some examples and what's the formula for correlation. This is the formula for correlation, but you don't get overwhelmed by this. It's okay, nobody remembers this, but it is important to know how it is formed. So it is basically we are standardizing the covariance between two variables. Okay, covariance is basically that if how is one change of one variable affecting the other change in other variable. Okay, and we're just standardizing it, okay, by dividing it into the square of the sums. Okay, and if you see this example, a correlation of 0.798. Okay, so it's almost perfectly equal to 1. You see that as one is increasing, the other one also is increasing. Now here and there some randomness is there. That's why it's not perfectly 1. Now one more example could be -0.772. Here you can see as one is increasing, the other one is decreasing. Okay, and here if you see, it's about 0.5. You see that there is some correlation. Okay, that as one is increasing and the other one is increasing, but not much as seen in the previous one. And here we see that 0.05, it's almost equal to 0. Now you see that there is no correlation at all. As one is increasing, it can increase, decrease, you never know. Okay, so let's take an example and solve it in Excel. So the question for you is first, find the correlation between the resting blood pressure and cholesterol. So I'm asking the audience, what do you think at a first glance? So what do you think? What could be the correlation between blood pressure and cholesterol? Any answers? Can you switch to the last slide? This one? And you can unmute and say, because I won't be able to see your chat. Okay. Okay. So coming to the question, what do you guys think? What could be the relationship between blood pressure and cholesterol? Any answers? Just see the chat. Can you tell me which slide, Abhishek? Guys, any answers for this at least? Okay. I'll just wait for 1 minute for this. Relationship between, testing blood pressure and cholesterol. Any answers if you can? Okay, no problem. So we'll just see what it is. Now I've taken this data set from Kaggle. If you guys don't know Kaggle, then I'll just explain, just give an overview of what it is. So Kaggle is basically a website which is like the bread and butter of all the data sets which are required for data science or business analysis, etc. So here you find everything, and if you're aspiring to be a data scientist or a data analyst or a business analyst, I believe it is very, very important, to bookmark this page and see what kind of data sets it has. It has various competitions as well. You can participate and also get to know how you're performing after what you're learning, application of those learning. And here you see all those data sets. And these are all not like people have randomly put it. These are actually, sourced from, valid and authentic websites. Okay. For example, this is the one that I've taken. Okay. And you see that this is actually taken from this ucieducation.com. Okay, and I've taken this listing blood pressure and cholesterol for an example. Okay, so coming to our example, I'll just show you how the data looks like. Yep. So if you see, there's a resting blood pressure and there's the cholesterol values. I've taken it from there directly, and we'll find out what's the correlation between these two. So first thing is, as you know from the formula, nobody remembers the formula. Just see how it is, and you can form it. Now, if you see, first we need the x square and the xy, etc., etc. So let's find out them. Okay. And then we need the other parameters as well. So what's the count of it? What is the sum of blood pressure? What is the sum of cholesterol? What is the sum of square of blood pressure? One, and also sum of xy. Now let's break it up, right? There's a big formula, so we'll break it up into three parts. First, the numerator, which is sigma of xy, sum of xy minus multiplication of sum of x into sum of y divided by count. Okay, and let's see the first part of the denominator, which is this part. So sigma x square minus sigma x whole square, right? Sigma sum of x square minus sum of x whole square divided by the count. And similarly for y, sum of y square, sum of y whole square divided by the count. And if you combine all these, right, numerator divided by square root of this, numerator divided by SQRT, this. Okay. So this is the correlation what we got for blood pressure and cholesterol. Most of us might think, and even I too at the first glance thought that as blood pressure increases, cholesterol level increases, and I thought there will be some positive correlation. But here you see, it's just 0.12. It's almost like it's negligible. And if you look at the scatter plot of it, see, this is how it looks. It looks random. It's like no correlation at all, as what was mentioned. Correct. So if you come here, now this is what we created from the formula, right? Now Excel also has its own inbuilt functions. or in Excel it is actually Corel, and you just have to select this one, X variable and the Y variable. So Excel function also gives the same output. The Excel function, I mean, it's an inbuilt function, right? And anyone can do it. So that is the problem, right? Until unless you know what is happening in the backend, you shouldn't actually do it directly. So this is what it is. So the formulation of all correlation is formed like this. And there is one more way you can actually do, correlation. If you go here and go to data analysis, not many of you might have this, but it's an easy way to get it. And just select, there'll be correlation here. Yep. And just select the input range, both of them, first low variable. And the output range, if you just I just put it over here. Okay. And this is what you usually see, right? X and Y over here, X and Y are in the columns and rows, and this is what you see. And this is how it is. This is just for two variables. And if you want to find out for third variable, right? For example, if you want the correlation between even maybe heartbeats per minute, right? Right. You just find out the data, populate it here, calculate everything. Yeah, you can find it out by the formulation method or the correlation method also, or using this. Okay, you'll have the correlation between all three. So that is what correlation is. So it is basically the strength of how two variables are. Okay. And guys, if you have any doubts, please let me know or type it in the chat box. I'll see. Yeah, Abhishek, that is what I would also think. Cholesterol will rise, but as we see what we saw from the data, it's actually not that. And guys, just stop me whenever you have a doubt or anything. I'll be ready to answer. Okay. You can raise your hand in the. Okay. Now we'll see. One important thing is correlation does not imply causation. Okay. Both are two different things. It's not like one variable is actually causing the other variable. Okay. Let's take an example. Okay. Now, just because two data sets are correlated doesn't mean there's a cause and effect. Okay. See, this is a real example. Sales of ice cream and deaths due to drowning is correlated. Okay. Now, so what is the meaning of this sentence? It means that as sales is increasing, the deaths of drowning is also increasing. But it doesn't mean that. But is there any direct link to it? Is the say increase of sales of ice cream causing this? We don't know, right? It's not. It's obviously no. So see, both of them increasing is a fact, but it doesn't mean that ice cream is causing death. It is correlated because as ice cream sales are more in summer, the number of people also, number of people who swim in rivers also increase in summer. So thus, by very bad luck, the cases also are increasing. You know, so that is why even though they are correlated, it doesn't mean that they're causing one another. So it is important to understand what is the overall umbrella as well. So here, if you see, they're correlated, they're related to summer, but so though these two are not related to each other. So correlation doesn't mean causation, and so that's why it is important to understand the variables that you're analyzing. Okay, so correlation doesn't